So guys, this is the buzzer. As you can see, it is giving a distress call. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can use a PIC16F877A microcontroller to run emergency sequence tune on passive buzzer. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version, as you can see. Then guys, this is the buzzer over here. And guys, as you can see, it has only 2 pins. On the right side, you have a positive sign here. The pin above which you have a positive sign, this is your power pin. And the other one where there is no sign is a ground pin. Now guys, to connect it with the PIC, it's very simple. Just connect the ground pin directly with the ground of the PIC and power pin with the any available digital input output pin of your PIC. And I'm going to use the pin number C2, that is pin number 17 of the PIC16F877A microcontroller. So guys, there are basically 2 types of buzzer. One is an active buzzer, and another one is a passive buzzer. And this is the passive buzzer we are using here. The difference is that in case of an active buzzer, either 1 or 0. If there is a 1, it means the buzzer is on. It will beep like a normal bell. In case it's 0, it means it's off. But in case of a passive buzzer, you have more options, like you have to send a pulse. Whatever the duty cycle is, like if your pulse has more delay, like you send a 1 and 0 and there is a delay in between. If the delay is higher, it means the beep sound will be different. The lower the delay is, the beep will be more smoother. So for a 1 millisecond delay, you get a perfect beep. So that's what we will see in the micro C4 PIC programming. So let me first introduce you to the hardware before we get to the programming. So guys, this is the hardware over here. As you can see, this is our passive buzzer and this is the PIC16F877A microcontroller. So this is as simple as that. This is our hardware. So guys, let's get to the micro C4 PIC to get started with the programming. So guys, this is our micro C4 PIC. Let me zoom in. As you can see, I'm going to use a version 7.2.0. You can use a higher version as well. Latest version is always the better. Click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project, whatever you prefer. I write Buzzer Passive Tutorial LM1. And this is the path where the code files will be stored. And select the microcontroller. I'm going to use a PIC16F877A. And the crystal I have at the pin number 13 and 14 is 20 MHz. Click on Next and Finish. So guys, this window will pop up. Before you do anything else, first of all, save your work. Press Ctrl S. Okay, save it. Now guys, our buzzer is connected to the pin number 17, that is pin number C2 of the PIC16F877A. Declare that pin as an output because buzzer works on the output pin only. So write down trace C dot F2 equals to 0. This command in case of Arduino is like pin mode output. This pin. So in case of micro C, trace is the register, 0 means an output, 1 means an input. Now initially the buzzer must be off, so we give PIC port C.F2 equals to 0. It's like a digital write, and 0 means low and 1 means high. So now give some initialization delay. This is not necessary, but I always suggest you give it in the one-time loop. 20 milliseconds will do fine, like this. Now guys, we can go for the forever loop. In this project, we only have a buzzer and that is initialized. Write down while 1, code starts here and here. Now guys, the next thing is we need to send a pulse. We have 2 types of buzzer. One is active and one is passive. The one we are using is the passive buzzer, and passive buzzer works on the pulses only. Whenever you will give a pulse at certain speed, it will start to like beep, and if you give it at a slower pace, pulses are at slow pace, then it will click, tick, 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 tick. Unlike the active buzzer, in case of active buzzer, you only give either 1 or 0. If you give a 1, it means it's on, and if you give a 0, it's off. It's like a normal bell. But this buzzer is different. Here you can also control the triggering speed, beeping speed, etc. So what we are going to do is that we are going to make a distress call. For that, we need to turn the buzzer on. for some time, and then it should turn off, and then again it should turn off. It's like blinking an LED, but here we have to send pulses for that. A pulse is simply like this: pin turns high and then the pin turns low, it makes a pulse. Now this is a pulse. Now for how long it should remain high, this will define that beeping of the buzzer. If you change this value, make it higher, it will start to click. At 1 millisecond, it will beep. So in our case, we need to beep it. So now this is a one pulse. Now we need to repeat this pulse to make it for a longer time, like it should remain on like teet, teet. This is like one tick, just a click. But we need to increase its value to certain limits and controllable limit. So we use a do while loop. Do, and then do while ends here, while bracket, and now we will need another variable counter, which will be used for the do while counting. Integer counter, initialize it, and initially the counter must be 0, counter equals to 0. Now the next thing is here, with every repetition of the do while loop, counter will increment by 1 like this, and here while counter is less than, I make it like 200. Now this is very important. If the counter increases the value of 200, then this looping will terminate and the buzzer will turn off, because buzzer only works whenever the pulse is continuously being sent. Once this is completed, the pulse is no longer being sent, so the buzzer stops. You will not hear anything. Now this is like if you want to increase the beep time like teet, teet, you want to increase this like teet, teet, then you will change only this value. This will increase the beep time. Now after execution of this loop, again the buzzer becomes 0, like it comes back to the initial state, else your program will start to click, because our condition is that whenever it's less than 0, only then the counter will work like this. Now guys, this is our one time, like buzzer will be for this time. Now after that it have to remain off. For how long it should remain off, we should define that as well. I think half a second is enough. I will give you this code in the description of the video. There will be a Google Drive link. From there you can download all the Microcontrollers for PIC files coming with the code like hex file, C file, so you can play with the code. Now I am giving just a half second delay. For a half second it will remain off, and this 200 means like you can calculate the delays inside it for each command processing time. If you repeat them by 200, then how much delay? It's like minimum 400 millisecond of delay. Like it will remain on for 400 millisecond, and then it will turn off for half a second, and then it will keep on repeating. So let's build this code. Let me write it. This is the PIC16 programmer tool. I click on file, import. This is the code we just wrote. I click on write. Let me zoom out and let's get to the hardware before our code writes up. So guys, this is the hardware here. So I will power this up using this on here. See, you can see that it is giving a distress call. Let's increase the beep time. So let's increase the beep time. For that, let's get back to our Microcontroller PIC. Now here, to increase the beep time, you only have to change this here. I make it 400. Now the beep time will be doubled. Let me build this again. Let's write this. Okay, it's being written. Let's get back to the hardware. Let it write up. Now the beep time will be doubled. So guys, this is simple as that. I hope you guys learned something from this video. If you have any questions, you can ask them in the comment. So guys, meet you in the next video. Until then, have a great day and keep learning. So thank you very much for your time and patience, and have a nice day.